The Boomerang Probe. For 53 years, a mysterious titanium sphere drifted silently in orbit above Earth, and almost nobody remembered it was there. In 1972, the Soviet Union launched Cosmos 482, a twin sister to the Venera 8 probe, on a mission to land on Venus. But a timer failure shut down its upper stage just 125 seconds after launch, stranding the spacecraft in a wide, looping orbit around Earth instead. The lander itself was never ordinary hardware. It was built with a spherical titanium pressure vessel specifically engineered to survive Venus's surface, crushing pressure roughly 90 times that of Earth and heat close to 470 degrees Celsius. For over 5 decades, tiny amounts of atmospheric drag slowly pulled its orbit downward until May 10, 2025, when it finally re-entered the atmosphere over the Indian Ocean. Because its shell was built to survive one of the most hostile environments in the solar system, most trackers agree it likely reached the surface almost intact. The probe that was never supposed to come home to Earth did, 53 years late, and tougher than anything meant to burn up along the way. The Stalker satellite, it looked like just another routine Russian satellite launch. Then, 2 weeks later, it split in two. In late 2019, Russia launched Cosmos 2542 into orbit, and nobody thought much of it, until tracking data showed it splitting apart like a nesting doll, releasing a second object called Cosmos 2543. Together, the pair began closing in on an American spy satellite known as USA 245. Within weeks, they had settled into an orbit that kept them just 150 to 300 kilometers away, close enough to observe nearly every angle of the multi-billion-dollar reconnaissance craft. The U.S. Space Force publicly called the maneuvers unusual and disturbing. Russia insists its satellites are simply inspectors, checking on other spacecraft. Nobody outside Moscow really believes that. This isn't history, it's still happening in orbit right now. The wooden shoe. Its nose curled upward so sharply that engineers gave it a nickname that had nothing to do with space at all. The Soviet Union called it Lapot, their word for a traditional wooden shoe, because that's exactly what the MiG-105 looked like sitting on the runway. But underneath the strange shape was a real orbital spaceplane prototype, part of a secret program to build a Soviet answer to America's spaceplane ambitions. Between 1976 and 1978, it flew 8 real test flights, dropped from a Tu-95 bomber at high altitude, and glided back down under its own control. The pilot sat inside an insulated escape capsule that could eject independently if anything went wrong. It proved the concept worked. Then the Soviet Union shelved it anyway, redirecting everything into a different, more familiar-looking shuttle, Buran, the Ski Walker. This tiny robot reached Mars 26 years before NASA's first rover, and almost nobody found out until decades later. In 1971, the Soviet Union sent 2 rovers to Mars aboard the Mars 2 and Mars 3 landers. Each one weighed just 4.5 kilograms, small enough to hold in 2 hands. Instead of wheels, it moved on a pair of skis, shuffling forward inch by inch across the surface, tethered to its lander by a 15-meter cable. The design made sense to engineers raised on Russian winters, where skis outperform wheels on unpredictable terrain. But both missions failed within seconds of landing, and because of that failure, the rover's existence stayed classified for almost 20 years. The world's first Mars rover never took a single step. The Sky Reactor. This bomber carried a live nuclear reactor into the sky, 47 separate times. In the 1950s, the United States wanted to know if a nuclear-powered aircraft could stay airborne for weeks without refueling. So engineers gutted a B-36 bomber and rebuilt its nose into a 12-ton crew capsule, lined with lead and thick leaded glass to shield the pilots. Behind them sat a 16-ton reactor, generating 1 megawatt of power, though it never actually powered the engines. It was purely a test. Could a crew survive flying next to a live reactor? Every flight was shadowed by a second aircraft carrying paratroopers, ready to jump and secure the wreckage if the plane went down. The tests worked, the crew stayed safe, and the entire nuclear aircraft program was canceled anyway, buried under the weight of its own risk. The satellite killer. From the outside, it looked exactly like an ordinary Soyuz capsule built to carry cosmonauts into orbit. It wasn't. In the 1960s, Soviet engineers designed the Soyuz P as a weapon, a spacecraft that would quietly rendezvous with an enemy satellite, then send a cosmonaut out on a spacewalk to inspect it up close. If the target was hostile, the plan called for destroying it on the spot using onboard rocket mines. Engineers quickly realized the danger. Many satellites carried self-destruct systems designed to trigger if tampered with, meaning the mission could easily kill the cosmonaut sent to complete it. The program was canceled before anyone had to find out. A spacecraft built to look like transportation designed instead to kill. The Spy Lab. The U.S. Air Force announced it as a scientific space station, built to study whether humans could be useful in orbit. That was the cover story. Behind closed doors, the Manned Orbiting Laboratory was designed for one real purpose: putting astronaut spies into space to photograph Soviet military installations with a classified camera systems codenamed Dorian. Two-man crews would launch aboard modified Gemini capsules and spend 30 days orbiting the Earth, developing reconnaissance film by hand. The program spent nearly 6 years and over $1.5 billion in development and never flew a single crewed mission. By 1969, unmanned spy satellites had become good enough to do the same job for a fraction of the cost. The astronauts trained. The hardware was built. Nobody ever went. The atomic bomber engine. NASA once built a rocket engine that ran on nuclear fission instead of chemical fuel, and it actually worked. Project Nerva heated liquid hydrogen using a nuclear reactor instead of burning it, producing nearly 200,000 pounds of thrust with far greater efficiency than any chemical engine of its era. Between 1959 and 1972, engineers ran 23 separate reactor tests in the Nevada desert, and by the end of the decade, NASA had officially certified the engine as ready for a crewed mission to Mars. The technology wasn't the problem, funding was. As the Apollo program wound down, so did political appetite for anything nuclear, and Nerva was canceled before it ever left the ground. The flying saucer. In December 2025, NASA quietly launched something that looked more like a UFO than a spacecraft. DiskSat abandons the boxy shape that's defined small satellites for decades in favor of a flat disk, about the size of a small coffee table and barely an inch thick. That shape isn't just for show, it dramatically cuts drag in very low Earth orbit, while its flat surface generates over 100 watts of solar power without ever unfolding a single panel. 4 of them deployed successfully on their first flight, proving the concept works in real orbit, not just on paper. It's not meant to replace every satellite, but somewhere out there right now, the next generation of normal might already be flying in circles, shaped like a flying saucer. Space engineering has never been a straight line from idea to success. Sometimes the strangest, most impossible-looking machines are the ones that teach us the most, even the ones that never got the chance to fly.